All right, let's go. You've spent your whole life treating black holes like a news story from a distant country. Catastrophic, real, but happening somewhere else to someone else at some point. So far removed from your Tuesday morning that it doesn't deserve a second thought. That comfortable distance you've maintained between yourself and the darkest objects in the universe isn't safety. It's the universe's way of keeping you calm while it finishes setting everything up. Number 10. The claim was already filed. Step outside right now and look up at the night sky. Find any star you like. Pick one that looks stable, ancient, dependable, something that has been burning since before your ancestors walked upright, something that feels permanent in the way that only very old, very bright things feel permanent. I now understand this. That star is not permanent. It never was. Every star above you is in the middle of a one-way journey, and for a significant fraction of them, every star with more than roughly 20 times the mass of our sun, that journey ends in a black hole. Not maybe, not possibly, definitively. The physics doesn't negotiate. It doesn't file an appeal. It doesn't consider your feelings about the matter. The universe has already filed the paperwork, and the star you're looking at doesn't get a vote. But here's what nobody says out loud when they tell you that. The star being consumed isn't the disturbing part. You are living inside the gravitational field of Sagittarius A star, the 4 million solar mass black hole anchored at the center of your galaxy, the black hole your entire solar system orbits, every single day of your life. Every birthday, every ordinary Tuesday morning, every moment of joy and grief and boredom you have ever experienced has occurred while you were revolving around something that would unmake you without registering your existence. The Milky Way is not your home. It is a disk of matter organized by the gravitational dominance of a black hole, and you are 200 billion stars worth of debris caught in its architecture. The distance between Earth and Sagittarius. A star is approximately 26,000 light years. That sounds like a buffer. It sounds like enough space to breathe, but translate that number into something you can actually feel. Light, moving at 186,000 miles per second, the fastest thing that physically exists, takes 26,000 years to cross that distance. If a civilization had been sending a message toward Earth at the speed of light from the day the last woolly mammoths walked the Earth, that message would still be 16,000 years away. That is the scale of the gap between you and the thing that owns your orbit. And yet the gap is irrelevant, because the black hole doesn't need to reach you. It already has you. You are gravitationally bound to it. You have been since you were born. Your body, right now, in this moment, is being pulled toward it. The pull is weak at this distance. Weak enough that you will never feel it, never detect it, never have a single sensory experience that reminds you of it. But it is real. It is constant. And it has not stopped for even 1 second since the moment you came into existence. The universe did not wait for you to wander close. It arranged things so that you were always already inside. You didn't fall in, you were placed here. Number 9, physics will unmake you slowly. There is a version of falling into a black hole that sounds almost peaceful. You cross the event horizon, you feel nothing unusual, at least near a supermassive black hole where tidal forces at the boundary are gentler. And in that first moment of crossing, your subjective experience might feel entirely normal. Scientists have described it as a smooth, unremarkable transition for the right kind of black hole. There is a version of this story where the most catastrophic threshold in the known universe feels, from the inside, like nothing at all. That version ends the moment tidal forces find you. Tidal forces are the difference in gravitational pull between one side of your body and the other. On Earth, the moon's tidal forces are strong enough to move entire oceans, shifting billions of tons of water twice a day, every day, with casual cosmic indifference. Now imagine those same forces, not from the moon, which sits 239,000 miles away, but from a singularity so close that the distance between your head and your feet becomes gravitationally significant. The cells in your feet experience a stronger gravitational pull than the cells in your head. Not symbolically, not as a metaphor, measurably, destructively. The difference grows as you fall. It grows faster than you have any ability to respond to it. What happens to you is called spaghettification. That word sounds almost funny the first time you hear it. Physicists gave it that name with a kind of cheerful precision that masks how savage the process actually is. Your body gets stretched along the vertical axis and compressed along the horizontal. Your blood moves in the wrong direction. Your spine elongates before it ruptures. Every organ you have is being pulled toward the singularity with a slightly different force, which means your body doesn't die as a whole. It dies in sequence, piece by piece, layer by layer, stretched into a narrow thread of particles falling inward, each component of what used to be you, arriving at the singularity at a slightly different time. And here is the sentence that doesn't leave you once you've read it. This is not a thought experiment. This is what the mathematics describes, and the mathematics has been tested against reality and confirmed. The universe has this mechanism. It is operational right now, happening to matter falling into black holes across the observable universe, and the process does not register the difference between a star, a planet, a city, or a person who once had a name, and people who love them. Your body is made of atoms. Atoms are matter. Matter obeys physics. Physics says you stretch. There is no part of you, no consciousness, no accumulated experience, no grief or memory or sense of self that exists outside of physics and therefore outside of this process. You don't get to be an exception. You would stretch, you would compress, you would become a thin stream of particles falling towards something that will never know you were anything other than mass, and the universe would not pause, not even slightly. Number. Time turns into a weapon. Here is something the universe does to you so quietly that you have never noticed it happening. It does not give everyone the same amount of time. Time is not a universal river flowing at a constant rate for all observers equally. Time is elastic. It bends under gravity. It slows near massive objects. And near a black hole, it bends so severely that time itself becomes the most elegant trap physics has ever constructed. Because the trap doesn't need walls, it just needs to make sure that the time available to you and the time available to everything you've ever cared about are no longer the same thing. The effect is called gravitational time dilation. It is not a theory or a model or a philosophical position. It is a fact so thoroughly confirmed that your GPS system corrects for it in real time. I'll be every single day. The satellites orbiting Earth are moving through a slightly weaker gravitational field than you are on the surface, so time moves fractionally faster for them. The difference is microseconds per day, but it accumulates, and without the correction, your GPS navigation would be wrong by miles within hours. That tiny effect, that near imperceptible consequence of being slightly farther from Earth's gravity, is just the very gentle beginning of something that, near a black hole, becomes absolute. If you were hovering just outside the event horizon, close enough to see it, engines burning against the gravitational pull, theoretically still able to escape, time for you would slow to a crawl relative to the rest of the universe. A single minute at that depth might correspond to years passing on Earth. An hour of your subjective experience might encompass entire human lifetimes unfolding in the outside universe. And you would feel nothing unusual. Your heartbeat would feel normal. Your thoughts would feel normal. Time doesn't feel slow when it's slow. You don't experience the slowing because every process in your body, every chemical reaction and the electrical signal is slowing at the same rate. Nothing inside you compares the before and after. You would hover there, feeling fine, while everyone you have ever known ages and dies and is replaced by generations who have never heard your name. Now push closer. Approach the event horizon itself. For an observer watching from a safe distance, you never arrive. The light reflected off your body becomes increasingly redshifted and faint. You appear to slow, then freeze, then fade, a ghost preserved at the boundary, technically never seen to cross it. To the universe, you are still there, suspended, eternal, preserved in amber at the exact moment time stopped for you. But from your perspective, you cross, you go through, and the universe outside, which you can no longer reach, has continued aging without you for timescales you cannot imagine. You didn't leave the universe, you just became permanently unreachable to it, before you even had a chance to say goodbye. Number 7, you won't even die properly. There is a law of physics so fundamental that Stephen Hawking spent 30 years refusing to believe it applied to black holes, then spent another decade fighting to prove he was right to refuse. And eventually had to concede that the universe does not make exceptions even for the people who understand it best. The law is this: information cannot be destroyed. Every particle interaction, every event, every specific arrangement of matter leaves a trace encoded in the state of the universe. Burn a book and the information in it still exists, in theory, encoded in the motion and heat of smoke particles and ash, recoverable if you could track every particle with perfect precision. The universe is a perfect ledger. Every event is preserved somewhere in its consequences. Nothing is ever truly erased. That law is the closest thing to immortality that physics offers you. It means that in some deep mathematical sense, you persist. That every particle in your body carries your history forward into whatever comes next. That even death, the most brutal thing that will ever happen to you is just reorganization, not deletion. Take a breath. Let that feel like comfort for just a moment. Then came the black hole. For decades, the question kept physicists awake at night. What happens to information that falls into a black hole? The black hole grows when matter falls in, but it also emits Hawking radiation, a slow thermal emission that appears to contain no information about what fell in. The radiation is random. It is thermal noise. It carries no structured record of the star that collapsed, the planet that was consumed, or the organism that crossed the event horizon. And as the black hole slowly evaporates, as it radiates away its mass over incomprehensible timescales, the information about everything that ever fell in appears to simply vanish, not reorganized, not encoded somewhere else in the universe. Gone. This is the information paradox, and it has not been solved. Not really. There are proposals, frameworks, competing mathematical arguments, but no consensus, no proof, no settled answer. The paradox stands. What you need to understand is what you are structurally. You are a specific, unrepeatable, irreplaceable arrangement of information. Your memories, your personality, the particular firing patterns of your neurons, the exact sequence of experiences that made you the specific person sitting here right now, that is what makes you you and not someone else. And the deepest promise that physics makes, the quantum mechanical guarantee sitting underneath all of reality, is that arrangements of information persist. They transform, they scatter, they become unreadable, but they are never deleted. Black holes appear to break that promise. If you fall in, the universe doesn't remember you incorrectly. It doesn't scramble your story or confuse your details with someone else's. It forgets you entirely. You do not become death. You do not become transformation. You become deletion. You become the exception to the one rule that was supposed to mean you could never truly be gone. And the universe enforces that exception with absolute consistency for every piece of matter that has ever crossed an event horizon, without a single recorded case of mercy. Number 6, the exit that doesn't reach you. For a brief, genuinely hopeful moment in the 1970s, physics offered something that looked like a way out. Stephen Hawking, on doing calculations that had never been done before, combining quantum mechanics and general relativity in ways that should have been impossible, discovered that black holes are not perfectly black. They radiate. They leak energy. They slowly, imperceptibly, lose mass over timescales beyond imagining, until they eventually evaporate completely and disappear. For the first time in the history of black hole physics, there was an exit. Not a comfortable one, not a quick one, but a real one, backed by real mathematics. If black holes evaporate, then perhaps nothing is permanent. Perhaps the universe's most devastating structures eventually unmake themselves. Breathe. Let that feel like a window for just a second. Now look at the numbers. A black hole with the mass of our sun would take approximately 2 times 10 to the power of 67 years to fully evaporate through Hawking radiation. The current age of the universe is roughly 14 billion years, 10 to the power of 10. The evaporation timescale is not a million times longer than the current age of the universe. Not a billion times longer, not a trillion. It is longer by a factor so staggering that there is no analogy in human experience capable of carrying it. If you took the entire current age of the universe and used it as a single unit of time, one tick on a new, incomprehensibly slow clock, you would need to tick that clock 10 to the 57th times before the sun-mass black hole was gone. That is not a metaphor. That is what the math returns. Sagittarius A star, at 4 million solar masses, takes longer still, by many additional orders of magnitude. And here is the detail that makes the exit feel like mockery. The Hawking radiation leaking from Sagittarius, a star right now, is colder than the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. The black hole is not evaporating in any functional sense. The universe itself, at its ambient background temperature, is feeding more energy into the black hole than the black hole is leaking out. The exit exists in the mathematics, and the mathematics is correct. And the universe uses that mathematical fact to dangle the possibility of an ending in front of you while simultaneously arranging every physical condition to ensure that ending is permanently, cosmologically, absolutely unreachable. You will be dead before any of this resolves. Omkeinki, your atoms will have been recycled into stars that burned out before new stars formed to replace them. The sun will have swollen into a red giant, scorched the inner solar system, and cooled into a dead white dwarf. Every city, every monument, every record of human existence will be gone. Not ancient, not eroded, but genuinely gone in a universe that has aged so far beyond the current moment that our entire cosmological era would appear as a mathematical rounding error. The exit is real. The door exists. You just won't survive long enough to walk through it, and neither will anything you've ever loved. And the universe has known this since before you were born. Number 5. The math stops, you don't. At the center of every black hole sits something that physics has no genuine description for. Not because scientists haven't tried. They have tried with extraordinary rigor and creativity. They call it a singularity. But that word is not a description of what's there. It is a confession of failure. A singularity is the point at which the equations that describe physical reality produce an answer of infinity. And in physics, infinity as an answer is not a solution. It is the equation breaking. It is the universe doing something that the best theoretical frameworks human beings have ever constructed simply cannot follow. The laws of physics, quantum mechanics, general relativity, the standard model, arrive at the singularity and stop. Not because nobody has finished the calculation, because the calculation returns values that have no physical meaning. Infinite density, infinite space-time curvature, infinite temperature. These are not descriptions of a place. They are the technical term for our map ends here, and they apply to a location that is physically, undeniably, measurably real. What is inside the singularity? Nobody knows, not as a gap in data, not as a problem awaiting more research funding, as a fundamental, structural failure of the best physics we have. The theoretical frameworks that describe everything else in the known universe, the expansion of spacetime, the behavior of particles, the curvature of gravity, produce nonsense at the singularity. And the singularity is not hypothetical. It is predicted by general relativity, the same theory that predicted gravitational waves, time dilation, and the bending of light around massive objects, all of which have been confirmed to extraordinary precision. The singularity is the theory's most confident prediction and its complete breakdown, simultaneously in the same place. Here is what nobody says plainly. If you fall into a black hole, you will reach the singularity. You will not have a choice. After crossing the event horizon, the singularity is not a direction in space that you can choose to avoid. It becomes a direction in time. In the warped space-time, inside a black hole, moving toward the singularity is as unavoidable as moving forward in time is for you right now. Every possible future trajectory you have leads there. Escape would require traveling backward in time, which is not a loophole. It is a physical impossibility enforced by the same laws that govern everything else. You will arrive at the singularity at a location where physics refuses to describe what happens to matter, where the concepts of location, continuation, process, and existence may cease to apply in any grammatically valid sense. The singularity is not a violent death. It is the point where the universe stops having a description for what you are. Your equations ran out before you did. That gap between the last thing physics can say about you and whatever actually happens, that is what you fall into. Number 4, 100 million silent traps. There is a number that astronomers state with quiet confidence and nobody seems to find sufficiently alarming. The number is 100 million. That is the estimated count of stellar mass black holes currently drifting through the Milky Way. Black holes form from collapsed stars, each carrying a mass somewhere between 5 and 50 times that of our sun, distributed across the galaxy you live in right now. 100 million black holes in your galaxy, and humanity has directly identified fewer than 20 of them. The rest are invisible, completely, functionally, physically invisible. A black hole in isolation, not actively feeding on a companion star, not surrounded by a glowing accretion disk, not generating the X-ray emissions that alert our telescopes to its position, emits nothing detectable. It produces no light, it sends no signal. It sits in space, bending space-time around it with perfect silent efficiency, and waits. There is currently no technology, no survey method, no theoretical framework that would allow us to sweep the galaxy and produce a complete map of every dark, isolated, drifting stellar mass black hole in it. They are hidden by the one property that makes them what they are. They do not radiate. Physics enforces their invisibility with the same mechanism that makes them deadly. The closest confirmed stellar mass black hole, a system called Gaia BH1, discovered not by a targeted search but by accident, by noticing that a star was moving as if it were orbiting something invisible, sits approximately 1,560 light years from Earth. In galactic terms, that is your immediate neighborhood. That is cosmologically next door. And it was found by chance. It revealed itself only because it had a companion star to orbit, a star whose unusual motion gave it away. The isolated ones, moving through interstellar space alone, with no companion, no accretion disk, no signal, so are undetectable with everything we currently have. 100 million black holes in a galaxy 100,000 light years across. The mathematics allows for black holes significantly closer than 1,560 light years. It allows for them in your immediate stellar environment. It does not promise one is near you. It does not promise one isn't. The universe does not post warning signs. It does not mark hazards on a map and hand you the map when you are born into it. It places 100 million invisible gravitational catastrophes inside the structure you spend your entire life moving through. And it leaves you to navigate that distribution with no information, no instruments capable of finding them, and no reassurance beyond the statistical likelihood that the nearest one is probably too far away to affect you in your lifetime. Probably. The universe uses that word like it means something. Number 3. The universe is already converting itself. Think about the most durable things in the universe and try to find something that permanently escapes black holes. Start with stars. The most massive ones live only a few million years before collapsing. Smaller stars are safer. Our sun has roughly 5 billion years left. Red dwarf stars, the most common type in the cosmos, can burn for trillions of years, dwarfing the current age of the universe by factors of thousands. That sounds like permanence. That sounds like something the universe offers as a counterweight to all this darkness. But even red dwarfs end. Churro. They cool into inert black dwarfs, cold, dense, dark husks of spent stellar material drifting through space. And those husks, given enough time, face something worse than a slow cooling: proton decay, the quantum mechanical instability at the heart of ordinary matter. On timescales of 10 to the power of 40 years, every proton in every atom of conventional matter in the universe may simply cease to exist. Not broken into components, not recycled into something else, gone at the quantum level, converting into radiation so diffuse it is functionally indistinguishable from nothing. Every black dwarf, every cold frozen planet, every moon, every artifact ever constructed by every civilization that has ever or will ever exist. Every atom in your body, preserved in whatever frozen tomb the far future arranges for you, what will dissolve at the quantum level, not violently, not dramatically, just quietly gone, over incomprehensible time, one proton at a time. What survives proton decay? Black holes. Black holes are not made of protons in the way that ordinary matter is. They do not decay on those timescales. While the rest of the universe's matter dissolves slowly into a thin, cooling fog of electrons and positrons and long wavelength radiation, black holes persist. And as ordinary matter thins out, as the density of free particles drops toward the minimum physically possible, the remaining black holes drift and merge and grow. Smaller black holes fall into larger ones. Galaxies, dark, cold, starless, stripped of every atom of ordinary matter by quantum decay, become vast, slow clouds of black holes orbiting each other, gradually approaching, merging, like you're producing gravitational wave pulses that echo through a universe too empty to care. The universe is not building toward black holes as a catastrophe. It is converting itself into black holes as an outcome, as the natural, patient, inevitable result of allowing physics to run long enough. The universe had stars and planets and chemistry and life for a cosmologically brief phase near its beginning. It has black holes for everything that comes after. You are inside the rare phase, the one where things other than black holes get to exist. The universe has been working on what comes next since before your planet formed, and it is not going to stop because you are still here. Number 2. The last light has an expiration date. There will come a specific moment in the far future, So far that every unit of time we currently use to measure things becomes meaningless, where years and millennia and geological epochs all collapse into rounding errors, when the last star that will ever form in the universe has already formed and already died. Not the last star currently burning. The last star that will ever burn. The final nuclear fire. The very last time in the history of the universe that hydrogen collapses under gravity and ignites into fusion. That moment will come. Physics sets its arrival with indifferent precision. After that moment, the universe does not go dark all at once. It goes quiet, slowly, over timescales so vast that compressing all of human civilization into a single second still wouldn't give you enough resolution to see the transition. The stelliferous era, the age of stars, the age you were born into, the age that produced every photon of light you have ever seen, ends. What follows has names in cosmology. The degenerate era, then the black hole era. The universe enters a phase in which the dominant structures are the supermassive black holes that once anchored galaxies, now floating in a void, stripped of everything else. No stars, no planets, no galaxies in any recognizable sense, just the ghosts of where they were, the mass that once organized them now concentrated into dark. Silent singularities separated by distances so enormous that crossing from one to the next at the speed of light would take longer than the current age of the universe. Many times over, no light is produced in the black hole era, nothing burns. The cosmic microwave background, the faint thermal afterglow of the Big Bang itself, the oldest light in the universe, the signal that confirmed the Big Bang theory and won a Nobel Prize, has redshifted to a temperature so close to absolute zero that it is functionally indistinguishable from perfect cold. The universe is not dark in the poetic sense. It is dark in the physical sense. There is no electromagnetic radiation being generated by any ongoing process, no fusion, no chemical reaction, no biological bioluminescence in any civilization on any planet anywhere. King, the only emission is the cold, near-zero whisper of Hawking radiation from the remaining black holes, and that radiation is so faint and so cold it doesn't illuminate anything. You look at the night sky and it is full of light, billions of stars, the Milky Way a visible smear across the dark. You are alive in what cosmologists call the most luminous, most energetically rich, most structurally complex era the universe will ever produce. It is not the middle of the story, it is the very beginning, and the universe has already scheduled everything that follows, in a schedule that runs for durations your mind cannot contain, and all of it is quieter and darker than this. Every direction you can possibly move through time leads toward the silence. The silence has been waiting longer than you have existed, Akratz, and it will still be there after the last black hole forgets what light was. Number 1. After the last one goes. This is where you have been heading the entire time, not as a metaphor, as a physical destination, a state of the universe that the mathematics points toward with the same confidence and the same relentlessness that it describes everything else. And the mathematics has not been wrong yet. The last black hole in the universe evaporates at a time so distant that the number required to express it contains more digits than there are atoms in the observable universe. You cannot write it out in any format that fits inside physical reality. 10 to the power of 10 to the power of 120. That is not an exaggeration employed for dramatic effect. That is what the calculation produces. And when the calculation has been right about gravitational waves, right about time dilation, right about the bending of light, right about every testable prediction it has ever made, you do not get to dismiss its most extreme outputs just because they are uncomfortable to hold in your mind. At that moment, if the concept of a moment still applies to anything at that point in time, the last particle of Hawking radiation is emitted. The last black hole is gone, and with it goes the last structure in the universe, not the last large structure, not the last galaxy or star or planet, the last structure, the last thing that was distinguishably a thing rather than an undifferentiated background. The universe has spent its entire existence converting complexity into simplicity, order into entropy, structure into noise, and it has finally finished. And now, the thing you carry out of this video into your night. You exist in the only window the universe has ever produced or will ever produce in which matter could organize itself into something aware enough to look up and ask why. Not humanity broadly, not civilization abstractly, you your specific awareness, your ability to feel the weight of this information pressing down on you right now. That awareness is a physical phenomenon. Neurons firing, chemistry cascading, a temporary arrangement of matter complex enough to model its own existence and the universe around it. And it exists inside a universe that began as undifferentiated plasma and is ending as undifferentiated emptiness. And between those two states of total featurelessness, there is this, a thin, improbable, already cosmologically microscopic phase in which atoms could form and stars could burn and creatures could arise from the ash of dead stars and look at the sky and understand, even partially, what they were looking at. You are not in the middle of the universe's story. You are inside the only paragraph that was ever written in a language that meant anything. The paragraph started before you arrived. The paragraph is ending whether you are ready or not. The black holes are the last punctuation mark, and after the mark, there is no more page. There is no page, there is no book, there is nothing that knows a book was ever there.